listen, but I didn't write a whole lot for The Boy at the Window and The Rainy Day. But look at The Boy at the Window, okay? We're in a section that is talking about the heart, so obviously emotion, okay? We talked about how Leo Tolstoy, he used emotions to make the reader feel what the characters were feeling, and he had sentimentality. So at The Boy at the Window, Richard Wilbur, he uses the emotion aspect to appeal to his reader. We see the emotion of a snowman and of a little boy. So let's go ahead and read it together. But first, before we do, look at some facts about Richard Wilbur. Richard Wilbur, he was an American poet and teacher. He was born in New York City and taught at Harvard and Wesleyan universities. He won a Pulitzer Prize and National Book Award for his poetry collection called Things of This World. And this poem, The Boy at the Window, was taken from his collection, Things of the World. Gabby, put your history away. Okay. You guys already know, don't do other homework in my class. So if you guys are already doing homework in my class, Isaac, are you doing homework in my class? Okay, just do it after class. You'll have time, okay? Everything should be away, open to 180, okay? All right, so let's read about the snowman and the boy, okay? Seeing the snowman standing all alone in dusk and cold is more than he can bear. I'm not going to lie, when I was reading this and studying last night, I thought this boy was a little weird for getting very choked up at a snowman, but this is what we're going to read, so... So, seeing the snowman standing all alone in dusk and cold is more than he can bear. The boy, Austin, I'm reading. Guys, I'm reading. Please listen. The small boy weeps to hear the wind prepare a night of gnashings and an enormous moan. His tearful sight can hardly reach to where the pale-faced figure with bitumen eyes, which is coal eyes, returns him from such a God-forsaken stare as an outcast Adam gave to paradise. He's basically looking at the snowman saying he's alone, he's miserable, and he weeps at the sight of the snowman. So the snowman, it's talking about him, it's giving the snowman some aspects of personification. Okay, and here's where we see that. The man of snow is nonetheless content. Okay, giving a piece of snowman a human-like quality of contentment. Having no wish to go inside and die, still he is moved to see the youngster cry. So it kind of shows that the snowman has emotion of being moved or having compassion on the little boy. Though frozen water is his element, he melts enough to drop from one soft eye, a trickle in the purest rain, a tear for the child at the bright pain surrounded by such warmth, such light, such love, and so much fear. Okay, so it's just talking about this little boy. Maybe there's something else going on, but it's saying that he was feeling sorry for the snowman, and the snowman is kind of reciprocating those feelings of feeling sorry for the little boy, having those personification feelings. Okay, to look at page 181, The Rainy Day. Written by Henry Wadsworth Longfellow. You want to know who wrote this? Henry Wadsworth Longfellow. He wrote The Rainy Day. Honestly, this poem is kind of relatable sometimes to us when there are trials going on in our lives, or maybe we're just in like some sort of mood, maybe like a sad mood. But it's basically talking about how our life and how sometimes in our life rain must fall. We see that in line number 14. Into each life, some rain must fall, and that's actually a saying that is pretty common nowadays, and we get that from this poem, The Rainy Day, written by Henry Wadsworth Longfellow. So let's read it together. The day is cold and dark and dreary. It rains and the wind is never weary. The vine still clings to the moldering wall, but at every gust the dead leaves fall, and the day is dark and dreary. My life is cold and dark and dreary. It rains and the wind is never weary. My thoughts still cling to the moldering past, but the hopes of youth fall thick in the blast, and the days are dark and dreary. Be still, sad heart, and cease repining. Behind the clouds is the sun still shining. Thy fate is the common fate of all. Into each life some rain must fall. Some days must be dark and dreary. You want to highlight that word or that line, mark it. Into each life some rain must fall. Okay? That's a famous line that you do want to know. Okay? But this poem, it does sound pessimistic, obviously talking about the trials of life. And we see that rain is used as a symbol of expressing sadness, sorrow, heartache, trouble. So yeah, this poem sounds pretty pessimistic. But there is still some optimism toward the end when it talks about, be still, sad heart, and cease repining. Behind the clouds is the sun still shining. Thy fate is the common fate of all. Into each life some rain must fall. Some days must be dark and dreary. And basically this is saying, behind the clouds, after the trials, there will be sunshine. There will be good times. Obviously, sunshine is a symbol of the good times and the happy times of life. But in line number 13, it says, thy fate is the common fate of all. So basically, everyone goes through these trials. Everyone goes through these dark days. And the optimistic part of it is that you're not alone. Everyone goes through these trials. Some days must be dark and dreary. Okay? We'll talk about page 182, but tonight, go ahead and read 183 to 185. We'll talk about remember and the servant on Monday. Okay? 183 to 185. 183 to 185. Yes, Elijah? Sure. Let me look for you. Come on. So, as soon as this loads, let's see. Yes, actually, there will be a reading quiz over this, page 183 to 185. Okay, so you want to know the author, read the story, find out what happens. We will have that over on Monday. Okay, go ahead and put that away. Take out your grammar books. Sorry? Okay, page 151. Actually, that's next week. Back 1 week. 135. Actually, let's go over. Yes, page 135, exercise A, number 6 through 10. And if you did the rest of the exercise for extra credit, you can come show me after class. I'll mark that down. But let's go ahead over 6 through 10. Number 6, mining iron ore is a chief source of income for the people of Newfoundland. Give me my verb here, Isaac. My verb. Mining iron ore is a chief source of income for the people of Newfoundland. Is, awesome. Is my verb. What's my subject here? What is? Class? Mining is, so therefore mining is my gerund. I would underline that. But what would be my entire gerund phrase? Mining iron ore, so that's what I would put a box around, okay? Number 7, mastering basic mathematics is an important goal for elementary school children. What's my subject here, Andrew? My verb here, sorry. Is, who or what is? What's my subject, Austin?
The subject is basic.
Not basic. Okay, who knows, Maya? Not mathematics. And an ing, we're looking for gerund phrases. Good, it is mastering. Mastering is my gerund, used as my subject. Used as the subject. It is the subject. Okay. Mastering is my subject. What would I box? What's my entire gerund phrase? Elijah?
For number 7,
Yes.
mastering basic mathematics.
Awesome. I would box mastering basic mathematics. Adrian, give me my verb in number 8, please. Stephanie made herself ill by eating too much of the delicious dessert. Good. Who or what made? What's my subject, Ricky? Who made? Number 8. Please pay attention, class. Stephanie is my subject. Good. Stephanie made herself ill. What it would be by eating too much of the delicious dessert. What is eating, class? Good. It is our gerund, so that's what we would underline. What would we box? What would we box, Jesse? Eating too much of the delicious dessert is the entire phrase. All of its modifiers is what we box. Okay, so what would the entire phrase be used as? Let's go with Doug.
The whole phrase, everything?
What's it used as?
Oh, is it used as a predicate nominative?
Not a predicate nominative. What's the word right before the word eating?
Oh, by.
By. Okay, what kind of word is that?
Prepositional phrase?
Good, it is a prepositional phrase, so what would eating too much of the delicious dessert be?
Prepositional.
No, what do prepositional phrases need?
Oh, the other word?
Not a linking verb. Look at your examples or your rules. Identify the use of each phrase by writing subject, DO, PN, OP, or AP. Who can help him out? Sophia? It is the object of the preposition. So, yes, you got it right. It is a prepositional phrase, but prepositional phrases need objects. And that gerund phrase, which is a noun, is used as the object, okay, of the preposition. Number 9, when God saw Abraham's unquestioning obedience in placing Isaac on the altar, he spared Isaac's life. Okay, so obviously we're not looking at he spared Isaac's life. That's not where my gerund is, but my subject would be he. Spared life would be my DO. But let's look at the dependent clause. When God saw Abraham's unquestioning obedience in placing Isaac on the altar. Okay, what would I underline here? What would be my gerund? Let's go with Jaden. Huh? Number 9. What do I underline here? Not this one, but good try. This actually, unquestioning, would be a participle used as a adjective here describing obedience. It's saying which obedience, the unquestioning obedience. So make sure you guys are watching for those. Okay. We need to look at what the gerund is functioning as. In this case, it is placing. Placing is my gerund. What would I box? Placing Isaac on the altar. Awesome. So what would that be labeled as? Amethyst? Good. An OP, object of the preposition. Number 10, the guard's assignment, keeping unauthorized people out, kept him busy. What's my subject here, my verb here, Sophia? My verb. The guard's assignment, keeping unauthorized people out, kept him busy. Who knows? Maya, do you know my verb? Not an... Okay, Ricky, what's my verb here? Two for two, Ricky. Okay, don't get a third strike. Adrian? Kept is my verb. Who or what kept? What's my subject here? Austin?
Guard.
Not guard. Okay. Who or what kept? Did the guard kept? Or the guard's what, Austin? His assignment is my subject. Okay. So what would keeping unauthorized people out be? Okay. Gabby, what do I underline here? I would underline keeping. What would I box, Lena? Good. Keeping unauthorized people out. Avery, what is this used as? It is an appositive. Oof. It is an appositive explaining what the assignment is. His assignment is keeping unauthorized people out. Okay? Go ahead and turn to page number 136. Okay, so we learned how to diagram subjects and verbs. We learned how to diagram direct objects. We learned how to diagram indirect objects. Now we are diagramming gerund phrases that are used as those functions. Okay, so for example, okay, so the way that I would diagram, where is my marker? The way that I would diagram a gerund phrase is on stilts. Okay, so all the time I would diagram a gerund phrase, or actually not a stilt, a stair stepper. Okay, so whatever my gerund phrase or my gerund would be, it would be on a slanted line. So your example gives your book gives an example of the word writing. Okay, writing is my gerund. I would put it on the line like this. Okay, all the time that's how I would diagram a gerund, on stilts and a stair stepper at the top. Okay, and then whatever it's used as, whether it's the subject, whether it's the direct object, whether it's the indirect object, that's where I would put it. So for your example, look at your example. Writing your assignment in a notebook is good practice. My subject is writing your assignment in a notebook. All of that is my gerund phrase. That would go on stilts in the subject's place. Okay? And then your verb would go normal, is who or what, practice your PN. All of that would go normal. Okay? But the only thing different, you would put your phrase on stilts. Okay? Look at it used as a direct object. We enjoy eating homemade ice cream. We is my subject, enjoy is my verb. What do we enjoy? Eating homemade ice cream. Notice how eating is on stilts. And then notice how there are direct objects within that phrase. Okay, so wherever the direct object is, we know that. It just goes straight on the line like this. Okay, doesn't go through. My DO goes here. So whatever the DO is of the subject, that's what I would put it on the same line. In this case, eating is my noun. Ice cream would be a DO. Eating who or what? Ice cream. So that's why ice cream is in that direct object spot on the stilts. Okay? Used as a predicate nominative. The problem is applying the mind to the task. Same thing. Problem is my subject. Is my verb. Since it is a linking verb, I do have a predicate nominative here. My line is pointing back to the subject, but applying is still on those stilts. Applying who or what? The mind. Mind is my direct object. Okay? But notice the object of the preposition. Okay? This one is a little different. Notice how it's still on stair steps, but not quite on stilts. Okay? So the stilts is this part. Okay? But then it's still on a stair stepper. Okay? So we diagram our object of the preposition. We have our preposition going down. Okay, wherever it's going under. So our preposition is going down. Let's say it's the word by. Okay, and then whatever our OP of a gerund is, that would be the object. It just takes the place of a normal object. Okay, that's how we diagram object of the prepositions. And then appositives. The way that you diagram appositives, so let's say it's explaining the subject, you would put that in parentheses next to the subject. Okay, so my subject would be here. My verb would be here, but let's say I have an appositive. With any appositive, that's where I would put it on the line. But if it's an appositive of the subject and it is a gerund phrase, then I would put it on stilts, but still in parentheses. That's how we diagram appositives. If it's an appositive of the DO, same thing. Okay? If it's explaining subject, verb, DO, you would just extend the line and put that in an appositive. Okay? If it's an appositive of the IO, okay, your IO would be here. It would just be an extension on here with stilts. Okay? That's how we diagram a positive. If it's explaining something, it goes in parentheses on our diagram. Okay? That's how we diagram a positive. So let's look at number 1. Okay, go ahead and pull out a sheet of paper, or you can use the paper that you did yesterday when we were diagramming, or the other day. I can't remember if it was yesterday. Let's work on these together. Go ahead and start diagramming number 1. If you have any questions, please let me know, and I'll explain it to you again on the board. You're diagramming you don't have to diagram ordinary prepositional phrases and single word modifiers, so like the word the, or if it's an adjective, okay? So you're diagramming the subject, so find the subject, you're diagramming the verb, you're diagramming any complements like a direct object, you're diagramming any phrases like we just learned, a gerund phrase, okay? Number 1, Ricky. You gotta be paying attention. No, I'm gonna show you on the board. Okay, so number 1, the most difficult task was organizing the things in my closet. This is how I would diagram number 1. Okay, what's my subject, class? Task. Okay, most is not a noun. Okay, it has to be a noun. Okay, task was. What kind of verb is was? Action or linking, class? It is linking, so note that my line is pointing back to my subject, okay? What goes in this spot? My predicate nominative, class? What was? Good, organizing the things in my closet, okay? So I would put that on stilts. Organizing here. What are you organizing, class? Things. So things would go as a direct object on our line. Okay, and if you wanted to diagram your prepositional phrases, you could. In closet would go here, my. But obviously, not everybody would want to do that, okay? So that's how I would diagram it. Task was organizing things, okay? Let's do number 2. Number 2, Erica, our youngest daughter, enjoys cooking meals for the family on weekends. Go ahead and work ahead if you've already gotten this. I'm going to put number 2 on the board. What kind of verb is enjoys, class? It is action. So our line goes straight up, not back to the subject. Okay? What does she enjoy? What does she enjoy cooking? Meals. Okay, so this is number 2. Erica is my subject. Enjoys is my verb. Cooking meals. But I think we're also supposed to be diagramming a positive. So let me show you how I would diagram our positive. Our youngest daughter. Okay, so Erica is my subject. My positive would be daughter. So that goes on the same line since it's explaining who Erica is. Austin, please sit up. Okay, so that's how I would diagram a positives. Okay, tonight for homework, you want to do 6 through 10. 6 through 10 diagramming. Okay, if anybody has any questions, ask. If they don't get it, I can try and explain it again. But I don't want you guys to get to a quiz or a test and not know what you're doing. Yes? What do you mean arrow going up? Just come show me on the board.
How do you determine whether it's going up or like going down?
Oh, underneath?
Yeah.
Like this? It just depends. So the reason why it's underneath here is because it's in the object of the preposition spot.
Okay.
So instead of, like I said, okay, so for example, where did that go? Yes? I said to redo it, doesn't it? It says to redo it. Okay, so this is how I would diagram any prepositional phrases. Okay, so let's say Gabby went to the bathroom. Okay, Gabby is my subject. Went is my verb. I would diagram my prepositional phrases. To bathroom is my object. Okay. Okay, it's a prepositional phrase telling us where she went, relating Gabby to the bathroom. Okay, so that's why whenever gerunds are used as objects of the preposition, they go on this line.
Okay.
So it's not quite an object, like just one word object. It's a phrase object.
Okay.
So that's why I would do a stair stepper down here. But it's still in the same spot as the object.
All right.
Okay?
Thank you.
All right, I'm going to write your homework on the board. Then you guys can be dismissed. Yes. Good. Don't forget, if you did your extra credit, come show me. Mm-hmm. Good. 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 For those of you in distant learning, if you didn't get the extra credit page, it is on page 135, exercise A, numbers 11 through 20. So if you want extra credit, you can come, or you can take a picture and send it to me, but it's on page 135, numbers 10 through 20 from exercise A.
We're going to take it. All right, welcome, distant learners. Make sure you throw your name in the chat so I know you're here for this class. Okay, all we have for this class is our test, so we're going to pray and get that started. If you haven't gotten it, message me real quick, and I'll send it to you. I think I sent it to most of you. Yuvia, I might have forgot to send it to you. I'll send it to you real quick. Okay, we're going to pray, and then we're going to take that. Any prayer requests? Okay. I pray for her dance, well, I don't know what you call him, not partner, teammate? Teammate? I'll just say that. Friend? Can I just say friend? Does that work? All right, I'll say friend just so I can remember. All right, Sophia's friend with that, she got COVID. Also, please help with their dad's situation. It's doing a little bit better. Continue helping that. Isaac?
Driving.
Yeah, when is that again?
Well, I signed up yesterday and I can start whenever I want.
So whenever Isaac's ready to kill someone, okay, he will go on the road. I'm just kidding. We'll pray for that. We'll pray for safety, wisdom. All right, any other prayer requests? The games, yeah, safety of travel, playing, obviously. Okay, any other prayer requests? What? You're starting it tomorrow? Oh, I'm not going anywhere after this weekend, man. Lena and Isaac are going to be on the roads. Oh, man. I'm just kidding. All right, we'll pray for that. Okay, yes, sir. Travel ball. All right. All right, sorry, more? So lots of people, driver's test. I might just say driver's test if I don't say all your names. Okay, you know I'm praying for it. Okay, we're going to pray, and then we're going to get started. Shh, everyone quiet. We're still talking way too much. Put your chair down. Okay, we're going to pray and then get started. Here we go. Dear Heavenly Father, Lord, thank you for today. Thank you for the beautiful weather you've given us all week, Lord, and all the blessings you give us on a daily basis. Please allow us to just be able to do our best on this test, Lord. I know the students prepared on Wednesday. I tried to help them prepare more yesterday. I'm sure that maybe they studied at home. Please help them to do their best. Starting off this grading period, this could really boost their grade in the beginning. Please help everything going on in all of our lives, Lord. Please help Sophia's dad with that situation to continue to bless it and make it get better. Also, please help all the students with their driver's training, Lord, for them to be able to be diligent, to learn the laws of the road, and to be able to execute them well, and to be able to become a great driver, to keep us all safe, and so we can stay on the roads. Also, please help all the basketball games today, Lord. Give us safety of travel, safety during the game, and the safety on the way back. Please help all the students, Lord, to have a great weekend. It's a Friday for us to finish today strong, finish that first week of this grading period strong, and for us to have a great weekend, get some rest, maybe have some fun with friends, whatever we might be doing. Also, please help Sophia's friend, Lord, in her dance class, for her to stay safe, Lord, to recover during this time of COVID, Lord. Please allow her to be able, for nothing to escalate in her situation, as I've seen some have it bad, some not have it bad, so please allow her to be able to have it not bad, Lord. Again, please bless all the students. Please help all the distant learners, Lord, as they're still working from home, to stay diligent in their work, to make sure they're staying on top of it, turning stuff in, listening during lessons. Help today's test. Help everyone with their weekend. In Jesus' name we pray, amen. All right, we're going to get started. UV, I'm going to send that test to you. I think I sent it to everyone else already, and we're going to begin that test here shortly. If you have any questions, just send it in the chat. I won't be on the video for you to see me, but I will see it.
All right, welcome to, let's see here. What is this? Geometry. That's right. Oh, rip. Camera's over here. All right, you know what? I'm not even going to turn off the camera today. Y'all get to see how this works. Why did Google just create a new tab? Sorry, don't look at the little window if you guys get motion sick. All right, because I just don't care. All right. There we go. What happened? Forward? All right, I have no idea what just happened there, but anyway. Let's go ahead and get going. Let's make sure we're not talking. Thank you, or singing, or humming, or any other way of making noise other than participating in class. Thank you. Scroll all the way down. All right, we're on number 20. Again, let's make sure we're not talking. I cannot compete with you guys, and we do not have much time today, so be quiet and sit down. What? Hurry up. Number 20. A, if the diagonals of a trapezoid are equal, then the trapezoid is isosceles. Okay, remember that means the legs are equal. All right. With that, we're told in parentheses in the problem to use Theorem 12 and Theorem 1. And then finally, in B, we're also told to state the converse. Oh, we're only told to state it, not prove it. Sweet. Of A. All right. So we'll do that in a little bit. In the meantime, first things we should do is probably make a diagram. So let's go ahead and do that. Bless you. So SAS? Okay, cool. So Theorem 1 is SAS. What is Theorem 12? Keep in mind they're all listed in the back. So Theorem 1 is SAS. Theorem 12, listen up, guys. Theorem 12 is hypotenuse leg. So that's what they're telling us to use. All right. Okay. Seriously. Shh. Yes, we're going to create right triangles, but y'all need to stop talking over me. Y'all need to stop being rude. Pay attention. We have 2 proofs left. Let's please let me get done with chapter 2. Let us all get out of chapter 2. Stop talking. Okay. Yes, if we can get through today without more interruptions. Because it's already now 6 minutes in. Insert, drawing, new. Okay, cool, here we go. All right, we got a trapezoid. We know it's going to be isosceles, so that's how we're going to draw it. It just shouldn't be like assumed that from the drawing. Does that make sense? Yeah. Okay. And we'll prove that it is, in fact, isosceles, other than the fact that I drew it that way. Yep, give me a minute. Give me a minute. Yes. Yes, I am. All right, first thing we need to do, though, is we're told the diagonals are, is it that they're equal? Or that they bisect each other? They're equal. Okay. So we're told that the diagonals are equal. Is there a reason why you're not just letting me draw? Cool, thanks. We're not going to really be able to convey that in, stop it, in the diagram because that would be too much. But we can at least draw our diagonals because we're going to refer to them. And then we're going to draw auxiliary lines. Since one of the things is a right angle, let's drop perpendiculars down, and we'll mention it in the proof. So we're going to draw a line, maybe, if the computer will actually let me. So we're going to do that. Yes, I held down shift. Yeah, that's the, if you guys ever want to make sure that it stays on a certain angle, you can just hold shift. And as long as you don't move the mouse too much, it'll actually make it perpendicular. I'm just going to go to this and do that. You guys can do it on paper. Like, there's nothing stopping y'all. All right. Well, that's just because we're on screen. Like, you don't have to make them darker. That's just because I want it to show up on the screen. Yeah. A, E. Why won't tabs just go where I want them to go? E. That's going to trigger me. Okay. Escape. Pull that up a little. And shrink down the text box. Oops, not that far. Too far. Too far. I got it. It's fine. All right, and then we need to label C and D, and then we're good. That's all they have labeled in the book. If you went ahead and labeled the other points of intersection, it wouldn't be wrong. Like, just to be clear. Again, you would think, but it's fine. The book doesn't, so I'm not going to. Just don't worry about it. Okay. All right, so there's our diagram. Let's go ahead and get started. Let's insert our table. The book has 13 steps, so let's go ahead and get into that. So table 14. Statements, reasons. Stop doing auto numbering. Is that a thing I can turn off? You know what? One thing. No, we're proving it's isosceles. So we can't state that it's isosceles. So we have trapezoid. Where was I typing then? That's fun. All right. I love it when you start typing, nothing happens, and you're just like, okay, great. What else did I mess up? Yeah. It's like, that can't be good. So if you see trap or something somewhere random, that's because I started typing trapezoid and I have no idea what happened to it. All right. Oh, rip. Insert. Okay. When you guys see me do that, it's because in Word, if you hit Alt equals, it creates a new equation. If you do Alt equals in Mac or in Google Docs, it zooms in. So like, I'm not trying to be dumb. I'm just using the wrong program. AC equal to BD. Hey Siri, go away. I just offended her. All right. No. Like I never said anything. All right. Yeah, we're going to draw our perpendiculars first. So we're going to draw D. Oh, so help me. DE is, there's not even the perpendicular symbol. Word does very few things right, but this is one of them. We need to specify specifically what we're doing. Especially if we're going to rely on that principle. In this case, the construction is actually what allows us to do that. Okay, it could... Yeah, basically. But just, that's how we did it. Don't worry about it. There's multiple ways to state the same thing in here. Yes. Yes. They have that as step 4. There's nothing wrong with putting it here. But I'm going to leave it in step 4. I'm going to come back to it. But that is perfectly valid and fine. And that's a thing of... yeah, that's the thing of it doesn't matter what order as long as we get it said. So... I have different letters, but yes. So angle DEF and angle CFE are right angles. Yeah, I don't know what just happened there. All right. So if I have, before we go to triangles, let's think this through. If I have perpendicular lines, what does that mean I have by definition? Nope. Yeah. No, perpendiculars. True. What else do I have? true, and you're like on the edge of it. We already know we have parallel lines. Oh yeah, that's true too. Not necessary, but it's true. If I have perpendiculars between parallel lines, what is that? The length of that perpendicular? That is my distance. So I can go through and state that DE and CF represent the distance between, I'm aware of the typo, AB and DC. Definition of distance between parallel lines. You have different letters than what I have? Yeah. I'm not saying you're wrong, to be clear. I'm just saying the book has different angles, or triangles. Before that, though, let me go through and state this. Guys, listen up. Chill. It's okay. Anyway, we can say that DE equals CF then. Because parallel lines are everywhere equidistant. You're probably used to the phrase are everywhere the same distance apart. Same thing. All right. Now we can go through and say that we have right triangles. The book says that we have triangle AFC and triangle BED are right triangles. Look, I'm with you. Okay, so we have DEF, hold on, DEF and CFE. Okay. Hold on. And then AFC. Okay. So AFC is a right triangle, and then BD, what did we say? BED? BED. So I think because the inside, the hypotenuse is the diagonal, and so that allows us to say that those are equal, and so then we have a side. So that's what they're doing. I don't know. We might. Give me a minute. Hey, Douglas. Thank you. Anyway, yeah. So definition of right triangle. I'm aware. Rip. Number 8. All right. So then, triangle DFC is congruent. Oh, I can't do that. Oh, right. Where's the congruence? So help me. View. Okay, I'm using that symbol. It's close enough. Shush. Fine. You're really going to be picky about this? All right, fine. Fine. Fine, fine, fine. Fine. Fine, fine. 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 Fine, fine. Oh, come on! What in the world? I know we've used it at some point. There we go. That's a weird congruent symbol, but I'll use it. Okay. What in the world just happened? Okay, anyway. So DFC is congruent to triangle. What just happened? Yeah, thank you. By hypotenuse leg. Because we had the hypotenuse equal, we had the distances equal for the parallel lines. So because we're told at the beginning the diagonals are equal. Typo? That should be an A. That's an A. Sorry. That's an A. Well, we were told the diagonals were equal. We proved these two pieces are equal, and then we proved we had right triangles. So the hypotenuse leg, easy. Okay. Number 9. Then by CPCTE, I have angle FAC is equal to angle EBD. Whoops. I swear I can type.
Are you kidding me?
What?
You don't need to use CPCTE for that. It's the opposite. It's a perpendicular. You know they're equal because they're both right angles.
FAC. Really?
Oh, I thought it was AFC.
Yeah. Anyway, and then EBD. is EBD. No, I'm also just pointing it out for me too. All right, so those angles are equal. I think we could all agree that AB is equal to itself. The reason it's written backward is because we're counting it in different directions. Not that it matters, but...
We have to do the other one that's like DE is perpendicular to CD.
Okay.
DB is perpendicular, or sorry, DE is perpendicular to BC.
Don't we already have that?
No, we have it parallel to the bottom.
That's fine. That's actually fine. So then I have another set of triangles congruent, biside, angle, side, and so I can say capital D. Triangle ABD is congruent to triangle BAC. Yeah, A, B, D. So this big one and this big one. Okay? Because once you prove those angles, then that's all you needed, because that was the last piece. So that was by side angle side, which was theorem 1. So now, then by CPCTE, AD is equal to BC, which are the two legs of the trapezoid, so by definition. All right, cool. Now that was part A and should be added to your proven statements. Okay, that was part A, should be added to your proven statements. Part B says to state the converse of A, so let's do that. The opposite idea, not necessarily, so switching your if and then. So if a trapezoid is isosceles, then the diagonals of a trapezoid, then its diagonals, I guess we could say, are equal. Okay? Which we could easily prove by contradiction. We're not going to show that proof here. You can also just throw that in your proven statements. The italics. Okay, so you guys are adding 20A and B to your proofs. You don't need that set of parentheses. What? Yeah, A, and then B, which is down here in italics. And then we're going to go on to 33 because it's the last one we have to do. And the only reason why I'm bothering to make sure all these get done is because we may need them in the next chapter. So, that's it. That's my reason. Because the way geometry works. Yeah, what? Yes. And then you have a quiz on Monday as well.
So this chapter 2 is over.
After the next one. I told you we had 2 left today.
What is it, 27?
33. 27 is just an explainer, and like we should do it, but meh. Like I don't care. All right. Everyone got this down? We good? Cool. Like I said, I hope no one gets motion sick. All right. 33. The sum of the... We're going to add this to our proven statements, so you can go ahead and do that now. The sum of the perpendiculars from any point in the base of an isosceles triangle to the equal sides is equal to the altitude on one of the equal sides. Then we were given the following hint to prove PE. I need to enter equation. That PE plus PF equals AD, or in other words, that PE plus PF equals AK plus KD. I'm aware I made a typo. Okay, so that's the idea there. Okay, that's our end goal. And let me see here. They also kind of give us a hint, how is PK drawn? So that's something for us to think through as we go through this. What? 33, yes. It's labeled at the beginning. All right, ladies, let's make sure we're not talking. Thank you. It's rude. No need for it. Thank you. Ha ha ha. Okay. All right, diagram is in your book on page 126. I will not be recreating it on the screen as a result because sanity. Even in my solution key, it literally just says see figure in the text. So, no. Yeah. All right, so this is a lengthy one. Hey, just be glad you're not writing them. So statements, reasons, 1, undo. All right, so we are given that we have an isosceles triangle. Right there in the question. Douglas, stop it. Not my problem. Go, if you're going. We have isosceles triangle ABC. We have, hold up. All right, we have PE perpendicular. Why? Perpendicular to AC. We have PF perpendicular to BC. And we have altitude AD onto BC. What? Right. That's fine. AD specifically is an altitude. That's why we're saying that. Yes, it makes it perpendicular, but it's perpendicular from the vertex to the midpoint. Not midpoint, to the side. So that's why that one's important to mention separately. We're also told that PF is perpendicular. We're told PE is perpendicular to AC. Where are we told that? Oh, the sum of the perpendiculars from any point in the base of an isosceles triangle to the equal side. So we're adding together PE and PF. We're told the perpendiculars. We have AD, which is the altitude. Is PK just a perpendicular? Is that what that is? Yeah, it looks like it. So let's draw PK perpendicular to AD. No, we have to say something about perpendicular. So exactly one perpendicular can be drawn to a line from a point outside the line. That's the same reason we just had in the last one, where it was construction of a perpendicular. It's just different wording. It's the same reason, though. Okay. Number 3. Hold up. You're way ahead of me. All right, we have an altitude. If we have an altitude, then what do I know? So AD is perpendicular to BC by definition of altitude. Let me see here. And then if I have two perpendicular lines parallel, or two lines perpendicular to the same line, that makes them parallel to each other. So let's go ahead and state that. So PK is parallel to DF, and KD is parallel to PF. Okay, so now let's go through and consider this. since KD, I'm sorry, what? Did I make a typo? No, I want KD on purpose. Yes, AD is true, but KD establishes what I'm about to say. Okay? So there's a reason to that madness. I just proved opposite sides of a figure parallel. I have a parallelogram. PKDF is a parallelogram.
Oh my gosh. It's a rectangle. Why are you playing with me?
Yes, it is a rectangle. We'll establish that in a minute, but we have to establish parallelogram first. By definition of rectangle. Rectangle requires definition of parallelogram, requires it to be a parallelogram with a right angle. All right. Actually, I don't even think we ever established that it's a rectangle, but yes, it is a rectangle. It's just not necessary. Now, because I have a parallelogram, that means I have equal sides. So PF equals KD. And again, you're absolutely right. It is a rectangle. It's just not necessary to deal with. All right. Now, I was told originally that it was an isosceles triangle. What does that tell me about its base angles? Angle EAP is equal to angle FBA. We just have to be more specific because there's more than one angle there. Yes, make sure you guys read over the rest of the proof at least. All right. Number 8. Okay. Can you please turn the temp up to like 72? Thank you. Number 8. That's why you set it at 75 with the fan on, and then it stays consistent. But no one else believes that, so I'm stuck dealing with what everyone else does. All right, moving on. Number 8. Let me see here. AC equals BC. It's understood. Siri, I didn't ask you. Go away. Did it just do LOL at me? Anyway. Nothing like a computer laughing at you. All right, number 8. Okay, just bear with me on this one because we got to get through this. Angle KPA is equal to angle FBA because two parallel lines cut by, forget it. We have two parallel lines cut by transversals, so we have then corresponding angles there. That's all I'm saying. Huh? Transversal is a line that cuts two parallel lines. We just say transversal because it's not necessarily perpendicular, but it's also not parallel. So KPA, hold on. KPA, FBA. FP is the transversal in this case. Wait, that can't be right. No, I lied. KP? No, KP and CB are the parallel lines. AB is your transversal. Yeah, okay. Hence why I'm just like you all just kind of have to go with that. We saw that one. All right, number 9. By substitution then, I can say that angle EAP equals angle KPA. EAP and KPA both equal FBA, so they're equal to each other. Okay, number 10. By identity, I can say that AP equals PA. AP equals itself. Here's where we establish that the right angles finally. Angle AEP and angle PKA are right angles. If I have right angles, what do I have? So delta AEP and delta PK. All right. So then that, as you can probably guess, leads to a congruency statement. So we have triangle AEP is then congruent to triangle PKA. And this is by hypotenuse angle. Hypotenuse angle. Why are you saying here? Okay, anyway. Number 14, PE equals AK by CPCTE. Because we proved those triangles congruent. So then number 15, real quick note, AD is equal to AK plus KD because the whole equals sum of all parts, which then allows me to state we're done. That's it. That's what we were asked to prove. Andrew, it's done. Let it die. All right. And with that, ladies and gentlemen, that is the end of chapter 2. Once your homework gets turned in and we take the quiz on Monday. Just rip that rug right out from under you. All right, anyway. No, give me a minute. Okay. I didn't. Why do you keep going back? I didn't even touch anything this time. Why wouldn't I? Guys, excuse me. Thank you. Okay, I don't know why Siri is flipping out or whatever else is happening. It's going to pop up again, watch. Amethyst. Final warning. I'm done. Okay, reminder, homework, due Monday. Okay? You have... Homework is due Monday. I've already given you guys how many steps are in each. Make sure you guys get it done. Quiz, Monday. That's 2 proofs. Okay, so make sure you guys are ready for that. In addition to that, you guys will have, or you guys do have that bonus quiz also due Monday if you want points toward that assignment. All right? Then we start 3.1 on Tuesday. So, yay, we'll finally be out of Chapter 2. Thank goodness. All right. Any questions? All right. Distance learners, I'll see you guys later. No.
Okay, DLs. Hey, class, quiet down, please. Can't even hear myself talk. Austin, didn't I ask you to be quiet down? Testing 1, 2. Testing 1. This is on. Well, can you get flash on now?
Battery's dead.
But it won't charge. I had it charging all hour last night, and it won't even do a charge.
Okay.
So,
Right now do this,
okay,
and I'll deal with it later.
okay. Sorry to interrupt. I know. Okay. 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 So,
Like my message.
yeah. Okay, so how do I get back to...
Okay, so you're gonna exit out. And then you should be back in.
Yo, pink pinky ring.
Okay.
Pinky ring.
Testing. There we are. Okay, class, we're about ready to start. Sorry, DLs. Shh. Doug, have a seat. Austin, quiet down. Okay, let me just see if I can plug my battery pack, whatever it's in. See if it's going to charge. We'll see if these get charged. Okay. Okay, I had to borrow somebody's mic to do this. Okay, so sorry about that. Shh. Okay. A few interruptions, few differences. The girls' basketball team left or is leaving, and probably waiting on Gabby because she can't get her act together and get things organized before she has to walk out the door. She has to make several trips back in the room, you know. But that's our one and only Gabby, okay? Would we want Gabby to change? Okay. Just kidding. Okay. You have a reading quiz. Austin, that's enough. Austin, don't go that direction. Okay, that's why it's not clicking. Shh. Okay. Doug, please have a seat. Gabby, bye. Okay. Now, let's focus in on this hour, guys. Okay, please. We're already late into this, getting late. Turn it on, duh. Okay, there's your reading quiz. Shh. This will go on 9.2. Okay, guys, please stop. This will go on 9.2. Okay, that first question it ends right there with through or first line. Okay. Still talks. Adrian, are you done?
Yeah.
Is there anybody not finished? Done? Anybody not done? Here's your answers. One, 3, 5, 8 are false. Okay. Okay. Isaac or Derek? How many? Did you even do this quiz?
So he's trying to figure out what
What's your points? Six. Or 7, yeah. Isaac? Andrew? Amethyst? Austin? All right. Maya? Doug? Sophia?
10.
Adrian?
6.
Jesse? 10. Ricky? 7. Elijah? 11? Okay, let's do our notes. We're on lesson 88, that's page 4 of your notes. Okay, stop talking. Okay, so I think I just gave you the first answer. What's the electric charge that is stationary on the surface of a charged object? Static electricity. What does static mean? Stationary. What is the SI unit of electric charge? Coulomb. I call it coulomb. What law states that the opposite charges attract each other but the like charges repel each other? Law of electric charges. Okay. What is the region around a charged object in which other objects are attracted or repelled by an electric force? The electric field. What are the arrows that include how a positive test charge in a field would move? Lines of force. Okay. What is the electric field which with even strength throughout called? It's a field. Uniform field. Okay. All right. Transferring the charges. Shh. The two major ways to transfer a charge between two objects are conduction and induction. Now, let me just go back to yesterday's notes briefly, okay, with an illustration. Please, I hear some talk. I want it to stop. Okay, let's just say, and this was an answer on one of your on 9.1, I think it was. Question deals with this. If two objects with charges are 4 feet apart, okay, and being 4 feet apart, the charge is 8, okay, 8 newtons. If the two objects that are charged come closer together halfway. Now keep in mind this, that when we're saying they're apart, we're going from point A to point B. Okay? But keep in mind the lines of flux, they form a circle. Okay? So that's where we get the radius aspect of this. Okay? Adrian, paying attention? That's where we get the radius aspect of this, because of the lines of flux. So, from point A to point B, if they are, 8 newtons, okay? And if we bring them in to 2 feet, okay? If it's 8 newtons out here, now what is it at 8 or 2? The radius has to be squared. If the radius is 8, what is it here? What is 8 squared? 64. Okay? Go a little simpler. If it's 2, what's the square? Because it's based upon the square of the unit or the distance. Okay? 4. Okay, so that's all we're doing is squaring our radius to come up with the force of it. Okay? So now, if the distances or And it doesn't matter necessarily the distance. The distance just gives us a realm of location. Okay, lack of a better term. But let's say that the distance between two charged objects is now 3 meters, or 3 newtons, excuse me. If we bring that in even 1/3, okay, what are we doing? We are we're strengthening our charge, okay? And that strength of charge is always based upon the square units of the distance, okay? So, if you need to get back 9.1 to answer that question more properly, you can. DLs, that might help you a little bit more on that aspect also. Okay, I just wanted to make sure that you had the idea of that before we go on to anything else here. Conduction. This is the transfer of a property of like thermal energy of electric charge through a direct contact. Okay? So, you have the illustration here in the picture. The pot of water that's been on the stove. The pot has gotten hot. Okay? Amethyst, that's one. The pot has gotten hot. Therefore, since the pot's gotten hot, the handle of the pot is connected to the pot. Therefore, conduction is transferring into the handle. Okay? And based upon what kind of handle depends upon how you're going to handle this hot pot. Okay? So conduction is just the transfer of a property of like thermal energy of electric charges through direct contact. Okay. When a negatively charged object or a charged plastic ball, okay, touches a neutral object, a rubber rod, extra electrons move from the charged object onto the neutral object, giving it a negative charge. Okay, because it's losing, basically it's in essence kind of losing its charge. Okay. So when a positively charged object of the plastic ball touches a neutral object, the rod now develops a positive charge because the ball takes some of the electrons away from the rod. Okay? So now it's gained it back to a positive aspect. Because the charged object shares its charge with the uncharged object, a charge imparted by conduction has the same sign, positive or negative, as the original charge. Okay? And that's where we get it's a joint effort because it's with a touch. Because the object shares, okay, I think it was the same slide. So here's the picture that goes along with it, okay. Number 2, because electrons physically move from one object to another, charging by conduction becomes a permanent charge, okay. Huh? It's what do they call electroscope? Look, and the rod's just touching it. Okay. Yeah. Because as you touch those electric scopes, the plasma charge goes to the outside. That's what it's basically talking about. Okay, so electrons are neither Here's your law of conservation of a charge. This law states that the total charge is the same before and after any interaction. Electrons are neither created nor destroyed. They're just merely transferred from one object to another. The plastic ball must lose exactly the same amount of charge that the rod gains. Okay? So there's not, even though we say it's gained a positive, it's lost a negative, it's not gaining more, it's just we're transferring one thing to another. Okay? So it's always there, and always has been, and always will be. Now, properties of charging by conduction. An object charged can be removed completely by bringing it into contact with the ground, such as grounding. And we kind of hit on this yesterday, that when you touch the knob of a door, you may get shocked. But if you have touched something else before you touch the knob on the door, then there's no static electricity going, and you're not going to get charged, because somehow your body got grounded. Okay?
That's why they're like, there's no lightning storm, stay in your car, because it'll strike the car with this metal.
Right. And because the lightning rod hits the car and it floats down over the car through the metal into the ground. Yeah. But it doesn't matter, because it's gone around you, not through the car. Yeah. Yep. Exactly. And that's why they put lightning rods on buildings, just so that it goes through that lightning rod instead of through the building, which buildings are made of combustible materials, and then if it goes through the building, then it's going to catch all that combustible material on fire. Huh? Say it again? Not necessarily, because you're not necessarily around an area. You're not in an area that has a lot of lightning going on. Okay? If you did, then yeah, you probably should somehow get a lightning rod put on the house. Okay? But also keep in mind that lightning always hits the tallest object, generally. 98% of the time, maybe 99. Okay? That's why in a lightning storm, you never want to be the tallest object on an open surface. Okay? Yeah. That's why in sports, if there's a lightning, and there's a thunderstorm going on and there's lightning all around, they'll cancel it, because your movement, the friction that you're creating on the ground, will attract that lightning rod and cause a revolt of a bolt from you to the lightning, and it's going to hit you. Okay? Huh? Like what? Like the force? The force would be with you at that point, yes. Yeah. Okay? Actually, it wouldn't be with you. It would be actually that the force be on you at that point. Okay? Induction, the second method. Shh. This is a process of imparting. Doug, one. The process of imparting electrical charges from one object to another without a direct contact, okay, between the two objects. So if a negatively charged ball is brought near one end of the neutral rod, the ball repels the electrons in the rod according to the law of electric charges, okay, because it's not coming into a direct contact. So if a positive charged ball, okay, is brought, Amethyst and Adrian, that's one more, okay, guys, please stop talking. If a positively charged ball is brought near a neutral rod, the ball attracts the electrons in the rod, giving the end of the rod near the ball a negative charge, because it shared and it gave away that electron. Okay? And the ball gained the positive because it received it. Okay? So a quarterback that throws a ball, a pass, okay? That's a negative charge coming out of his hand, but the receiver catching the ball talking about football since it's Super Bowl weekend, catches the football, that becomes a positive charge for the receiver. Okay?
What happened to it? I don't even understand.
I don't know. It's definitely not conduction or induction. So I don't know. Okay, let's try and finish these notes, okay? Got 10 minutes. Shh. The difference between induction and conduction. Shh. Induction must produce or produces 2 charges instead of 1. Conduction only produces a permanent charge. Okay? That's your 2 differences. A transfer, a temporary transfer. The similarity between induction and conduction is they both obey the laws of conservation of energy. Okay? They both obey the laws of conservation.
Brown, do you obey the laws of conservation?
Absolutely.
He doesn't obey the law.
Do I not have, is that not underlined? Nope, it's okay. It's in your notes as italics, so my bad on that. I forgot to cross off the underline. This should be letter D, I think. In changing my notes, sometimes I forget to change. Shh. This is letter F. It is. So the other one was letter E. It looked like a C. Sorry. Charging by induction allows a charged object to attract a neutral dug to. A neutral object by electric force. So like a balloon sticking to the wall during a dry condition. You've got this induction going on because the transfer is happening. So how can we make induction permanent? A permanent charge can be produced by combining induction and grounding. Example of this? Yep, everybody done? If a negatively charged ball is brought near the end of a neutral rod, the electrons in the rod are repelled to the other end of the rod, causing an excess of electrons at that end. If that end of the rod is then grounded, such as by touching it with a wire connected to the earth, the excess electrons will leave the rod and be displaced in the earth because of the ground of the wire. So removing the ground wire leaves the rod with fewer electrons that it had to begin with, because now they are transferred into the ground and they had left the rod. They're still there, they just were transferred to one place. Hang on, I have the bird calling me. Okay. Thank you. Not sure what happened, but thank you, Giselle. Let me, we're on slide 37, so hang on. Let me shut it down. Go down to 37, see if this helps. The computer froze is what's going on. It didn't help. So hang on, we'll try one more thing. Oh, we'll go to interruption. Then back to screen. All right, that helped. Thanks, Giselle. It's hard to keep track of 5 things at once, so my apologies on that. Okay. So hopefully you got an idea of what we were talking about without the pictures before this, okay? A positive charge still remains on the rod, even if the ball is taken away, okay? Because there's enough charge from the rod still there, okay? Not all of it was taken away, just what was shared to the ball. So the reason why producing a permanent charge on another object through induction does not affect the charge of the first object is because of grounding. The new charge on one object is balanced by slightly changing the charge of the earth itself. So grounding is the key to this. Okay. Charge carriers. Let me see where we're at in the notes real quick. You know, this would be a great spot to go ahead and stop. I know we still have about 4 minutes left, but we still have about a page and a half of notes left. So this would be a good place just to stop. Okay, so 9.2 is not homework. Austin, can I finish talking, please? Thank you. 9.2 is not homework yet. Quiz is still Tuesday. Okay. The only reason I postponed it was because of the girls that left for the basketball. So by finishing our notes on Monday, we can still do our test on Tuesday. And now all this will become homework on Monday, not tonight. So there is no homework for the weekend. Enjoy yourselves. Okay. Just don't get positively charged about too much this weekend. Okay. We'll see you later.